Hello and welcome to IB A-Level Learning Center with Mr. Tai. In this video, I would like to help you to solve a question related to Euler method to estimate the value of a function in a differential equation. This is a question in 2025 past paper, paper 2, times on 2. A financial analyst models the change in value of one share at dollars at time t minutes. After a report is released, she uses a differential equation, d square x over dt square plus 4dx over dt plus 3x equals 0. This is actually the second derivative. The equation can be written as the coupled differential equation dx over dt equal y and dt over dx equal -3 minus -4y. Actually, this question I help my student to solve all the above question from A to C. So now in this video, I'm only focused on the last question D here. We have the initial condition. Looking for that thing here. Initially, when the time is 0, the rate of change of the price of the share is -1, like $1 decrease every 1 minute. Okay, that's the meaning of this derivative dx over dt, the decrease of the share value every minute. That value is -1, the rate. Okay, for question D here, we're given an improved model. Okay, an improved model. Okay, so it is slightly different from the above here. The only difference is that on the right hand side we do not have the 0 but a new function which is x times sine t with the same initial condition, which is x equals 0 and dx over dt equal -1. Use Euler method with the t interval of 0.1 to predict the value of x when t equal 1. Okay, to solve this question, we need to write the equation from the differential equation. From this one, let me circle that from this one. Firstly, we need to denote that dx over dt here, dx over dt is a variable y, and we can call this is the first function, so that we can compare with the formula sheet to substitute the value into the provided formula sheet. So the new equation here, d square x over dt square plus 4. Now this dx over dt is the y, plus 3x equal x times sine t. Okay, I can arrange this formula by removing the term on the left hand side and put them on the right hand side, which is -3x and -4y. Okay, so this is the second function f2y. That we will compare with the mark scheme. I mean the booklet here. We have the booklet formula for the Euler method, with the time interval. The step h here is 0.1. H here is 0.1. The t will be denoted by an in the Casio calculator on the right hand side. The x will be the bn. And the y here will be the cn, the terms in the calculator. So here in the Casio calculator, firstly we need to go to the recur here. Hit the arrow button to go to the recur. There, enter the recur, and then we define the coefficient a, b, c in using this formula sheet. So an here is the time. So here we enter an and then plus the interval h, which is 0.1 second. Sorry, that minute, 0.1 minute, 1/10 of a minute. Bn is this one. Bn is bn plus 1, the next term, the next step. Okay, so bn here, bn, and then plus h here, the step 0.1 time the first function. The first function, go back to the thing I write here. F1x is the first function. It is the y, and y means cn 0.1. Let me enter 0.1 first. Sorry, point 1 here, oops, and then enter C1, huh? C1. But visit the next thing in the formula sheet, huh? F1. F1 is simply just Cn here. Execute. And then C plus 1, huh? Which is the Cn here. Cn plus hex the step 0.1, and then time the second function. Let me put a bracket, and then the second function is this one. X again. X is bn, huh? X is bn because the time is an. Okay, so x here is bn, and then sine. Let me put this multiplication here. Sine sine of t is an. Let me put another bracket, an, and then close the bracket for the sine, and then minus 3 times of x, which is bn, and then minus 4y, 4 is the cn, huh? Finish. Yeah, so here are the 3 equations in the recursion in the Euler method, which you use based on this formula sheet. Okay, now the next step is very important. We need to set up the hit execute, huh? We need to hit the set button here to choose the initial condition. Okay, hit set here, which is F5. Initial condition. The time start from 0 to 4 seconds, but actually we only need to find here given the time start from 0, and we want to find the value of x, which means the price of the stock at the time 1 minute, and therefore, and because the step is 0.1, so it will take 10 steps to go from 0.1 to 1, huh? 0.1, then 0.2, 0.3, 0.4, etc. And therefore I will choose 10 steps in the the end here. I can choose 10 steps, but I intentionally chose 15 steps so that I can see how the series goes. The time a 0 here is the initial time, which is 0 when we start the clock, or a time we choose to start observing the value of the stock. Okay, basically it's 0. Bn is the initial price of the stock x, which is given here, initial condition. The value is 0. That's a weird, huh? Okay, anyway, it is 0, and C0 here means dx over dt. Dx over dt is -1. Okay, so everything here are the condition, initial condition all set. Now just hit a set to go back to the equation, huh? And then hit table here, table, to see the step, and then let me move into, okay, so here we have the step, the table, and with it 0.1 minute, 0.2, 0.3, 0.4, etc., and just go up to 1 minute here, huh? 1 minute, and this is the price x. The column B here is the x, the price, the stock, which is negative 0.12 something. So you can use the cursor here to move there to see the value. Negative 0.172 when I round it to 3 significant figure, huh? And when I compare my finding here, the result here, with the mark scheme, visit the mark scheme here, I see. So my result is identical with the mark scheme, negative 0.171795, huh? Exactly the same thing. So visit the answer. The price of the stock after 1 minute is that value. Okay, so that's the Euler method. Thank you for watching.